Good morning. Thank you for giving us the opportunity to present the inventory to this audience and the online audience as well. So I'm Laura Cardenas. I work for Rothamsted Research, and I represent a large consortium of people in the UK working on this project. Okay. So just a quick overview. I will give the background to the inventory and show what the national emissions and the sources are and the trends. But then I will focus more on obviously the methane, which is the purpose of the meeting, and particularly on manure methane. So first of all, the aims of the inventory project is delivering emissions as well as the uncertainties and the projections for the UK and the devolved administrations from agriculture. We also provide maps at high resolution, special resolution, and we report greenhouse gases as well as pollutants, including ammonia and others as listed in the slide. This allows us to fulfill the UK national reporting requirements, to fulfill international agreements for various bodies as listed there, particularly the UN-IPCC and the Paris Agreement Enhanced Paris Framework. So the inventory for agriculture is funded and managed by DEFRA. We are formed by several organizations in the UK, and as I said, we cover greenhouse gases and ammonia from livestock and soils, and it's separate from the LULUCF land use change inventory that covers the carbon and sequestration, etc. The inventory runs in an annual cycle. We provide emissions at the end of the year using IPCC aligned methods, but also other European guidelines. The methods and the emissions are rigorously reviewed by international panels and agricultural sector experts. We have quite an extensive quality assurance, quality control system implemented, and we identify potential improvements and in order to improve the accuracy of the inventory and minimize the uncertainty. We apply key categories as the IPCC recommends. We use in the UK 10 by 10 kilometers special resolution using UK data from surveys, climate, etc. And it is considered to be one of the most accurate inventories in the world. But there is always room for improvement, of course, and we are all very open always to getting new, better data, better methods to improve the accounting of emissions. So here is the total emissions for 2021 for methane. Agriculture is a major source, followed by the waste sector, as you can see. So agriculture is an important source to kind of tackle. And we do have some verification of the inventory. This is part of the inventory program nationally. As you can see there, I don't know. Oh yeah. I don't know if you can see the mouse, but the lines that have no seasonality, these are the inventory data, because the inventory is, as I said, compiled in an annual basis. But the data is in agreement with, or is within the uncertainty of the data provided by the toll towers that are run by the Met Office. Using casting modeling, they can estimate the sources that cause emissions measured at the tower point. So we are confident that the bottom-up approach, which is the inventory approach, is in agreement with the top-down approach from the tall tower. So that's a way to verify our emissions. Then again, for 2021, this shows the specific sources. And as shown here, enteric fermentation is a major source, followed by manure. And the ratio is about 85 to 15 for the UK. So focusing on manure. So the inventory has undergone an improvement process. Before 2006, mostly followed tier 1 with some country-specific activity. And the trends showed were like this. Nitrous oxide produced the majority of the emissions in CO2 equivalent compared to methane. And there was a downward trend in the emissions. In 2010, for 5 years, DEFRA funded a large national program to improve the inventory and focusing on N2O and methane emissions. There was over £12 million spent to make all these improvements via experiments and modeling and searching the literature. And it caused a turnaround of the inventory. So methane then became a major source compared to N2O, as you can see there. Methane, the ratio completely got inversed. The global warming potential changed as well because the IPCC guidelines have been updated. And the main thing from the point of view of methane is that the calculations after the improvement program were based on energy balance equations, but using more country-specific data. For manure, it was a combination of IPCC and country-specific data. So the latest inventory after 2021, we've already submitted 2022, but it's not completely published, so I'm only showing here 2021. So 1990 to 21 data series. We see a decrease in emissions overall of about 15%, and this is mostly caused by a decrease in livestock numbers, about 15%, and the reduction in fertilizer use of about 35%. Here I show as an example, the livestock numbers have decreased for pretty much all the categories since 1990, except for poultry. Particularly dairy cows has been the largest decrease in numbers for the time series. So this reflects also in the methane emissions from both manure and enteric fermentation. As you can see there, enteric has decreased by about 15%, manure by about 9%. And also, the allocation of manure to the different, this is not the manure, the allocation of excreta to different systems. So that includes liquid systems, daily spreads, solid storage, which is the farmyard manure, and obviously digesters. But then this one here, the pasture range and paddock, is the grazing. So that is not a manure management system. So from all of the distribution of the excreta, the liquid system, so this is the slurry from dairy animals, so dairy cows is the most important one. So I will now go to explain a little bit about the IPCC methodology. And this is the equation you find in the guidelines. And I won't describe the parameters, but the main parameters are the volatile solids, the B naught, and the methane conversion factor. So the B naught is the potential of a manure to produce methane. So that is in the best optimum condition, how much methane the manure can produce. The methane conversion factor is the actual realization of that potential. So depending on various factors, how much methane is in reality going to be produced. The orange boxes just show what how the data or where the data come from. For the solids, we calculated from maintenance energy equation. The B naught is an IPCC default value, but that has been validated using data measured in Rothamsted by my colleague who retired, Tom Mr. Brook. And the methane conversion factor is an IPCC default value. This is what we do in the UK. So going a little bit more in detail on the MCF, as you can see, the guidelines in the various versions have revised the values the IPCC has revised the values they recommend. So from 1996 to 2019, which are the refinement guidelines, the values have been changed according to new data, new research. And particularly in the last two guidelines, the methane conversion factor is given as a function of temperature of the manure, but also in the 2019 is also taking into account the duration of the storage. So you can see that the guidelines are more and more trying to refine the methodology. So the emissions are affected for many, many factors, of course. What we call the NCF, or the realization of that potential, depends on the temperature of the manure, and the amount of solids in the manure, and what quality the solids are. Are they degradable or no? How long the manure is stored, how much the manure is how often it's being emptied, the tank is being emptied, whether it's inoculated, how anaerobic it is, what dry matter content, and whether the store or the manure management system is covered or not. But also the manure will form a crust naturally if it's in static conditions or relatively static conditions. And then the last one there is quite important, because how much manure is left in the facility after it's empty. This is also something that needs to be considered, because some emissions will occur from that leftover manure. So going now into some of the parameters, the volatile solids, as I said earlier, are UK specific, because it's based on the gross energy calculation for the animal activities, which include maintenance, lactation, moving, growing, all of that, and also the digestibility of the diet. So obviously what the animal eats is going to change the ratio of methane, the amount of methane produced, because it affects the rumen. So the data for those factors are derived from experiments from the UK. So we know that our solids are representative of the UK conditions. So I mentioned about the dependency on temperature of emissions. This is a combination of studies being in different locations, non-UK. And as you can see, although there is a lot of scattering in the graph, there is a slight indication of a positive effect of temperature on emissions. So it is expected at higher temperature, you're going to get more methane. Of course, there is variability, because the management of the slurry in a tank it is going to change, depends where you are. There are lots of different things, as I said earlier, whether it's emptied with frequency, how much is filled up, and how it's maintained, and etc. So the 2019 guidelines provide a tool to be a little bit more specific about the calculation of the NCF. And so my colleague Sarah Gillespie in Rothamsted, she's used the model provided by the IPCC to estimate the methane conversion factor, and in a way to validate what we use. And yes, you can see there, in yellow are the input parameters. So we tell the model what the temperature is. This is the air temperature, and whether the manure has been removed or not. And the model will calculate, as a consequence, the manure temperature. And it will simulate when the tank is full, when the tank is being emptied, and then according to that, when methane is being produced and how much methane is produced. So the calculations, as I said, they are in the guidelines, and the cells in yellow are the parameters you have to input, and the equation to calculate MCF is here that has a few parameters, including energy of activation, temperature, etc. They are constant, etc. And then we obtain an MCF, which is in agreement with the IPCC guidelines. So the data that we input then for dairy cows, just to give an example, this is what in average what the animal weighs. This is the amount of solids per head in a year, and the V naught, and also the MCF, which should be in percentage. Based on this, we estimate that an emission factor for a tank above ground is 11 kilos per head per year. But if we add together all the slow resistance that we have in the inventory, the result is about 30 kilos of methane per head per year. This assumes the tanks are not covered, but form across. And there is a suggestion in the IPCC guidelines of a reduction in methane when you cover the tank. And covers are considered also to increase emissions. So all of these assumptions are reviewed by an IPCC appointed panel, an international panel. And then I thought, as the last bit, I wanted to put the UK into the European context. And I reviewed data from many countries in Europe. As you can see here, the orange is the IPCC default value. This is the emission factor for methane. In green is the mean of all the countries. And the UK is above those two values, but is under what the Danish and the Dutch report. I did the same for the volatile solids, and then the UK is bang on the mean and the IPCC default. And in the case of the MCF, again, the UK is within the boundaries. So finally, the ratio of methane between manure and enteric. So again, I did a review of a few countries, and the blue bar is the mean. The error is the orange line, and the UK is just located here within the error. So in conclusion, the UK methodology is consistent with IPCC recommendations. We apply country-specific data, as much data as we have and as we can find, and is robust. The parameters and emissions we report are consistent with other European countries, but of course, we are always looking for improving the inventory. In order to do that, we need evidence. We need the evidence to be geographically representative of the country or at devolved administration, at least at devolved administration level. And we also need to know how much uptake there is for that particular measure. And finally, thank you again. And I just would like to acknowledge the colleagues from the consortium, as well as DEFRA. My colleagues here representing DEFRA. Thank you for attending. But we talk to DEFRA every week, and we make sure that we are in good communication with the funder and obviously the people that manage the project. Thank you.
Thanks, Laura. And you're okay to take some questions? Thanks. And thanks very much for sticking to time as well. Excellent. So we might have some questions online, but I'll open it up to questions in the room first, and then we'll see if there's any that have come up in the chat online. But any questions for Laura? Yes, George. We need a... Oh, yes. We have to remember to capture the sound, so we'll use the regular way.
The work is indeed. I just wondered on that graph, there was quite a difference between Denmark and France. And although you're supposedly using the same methodology, I just wondered if you understood why there was such a difference. Is it because French dairy cattle don't use sow stools and they're all free range, or is it something more than maybe just something that are applying different assumptions that are using the same formula?
So just for the people online, we'll make sure that, so the question is about what does Laura think might explain the difference between the European countries on the graph?
So every country will manage their manure differently. So in order to explain this difference, we probably would have to go into what it is that they do differently. As I said earlier, even the scatter plot on the temperature dependence of emissions, you can see that there is a lot of difference, and it's because it depends how much the slurry, for example, will be in the tank, or how long for, how long before it's emptied and refilled. So there are lots of different factors that will affect this, and whether they scrape the yards, and you know, even when you use the same methodology, if you apply country-specific data, you will tailor your inventory to your management, and every country has, as I said, different. So in the UK, we tend to, for example, house the animal for half the year because of the weather. Some countries like New Zealand, the animals are out all year, so then there is no manure. So I think you would have to look into the detail of the management and the diet, of course. So what they eat, if they are given concentrate, that's going to change the methane as well. Yeah.
Okay, thank you, Laura. Any other questions in the room on the inventory and all of the? Yes, there's a question over there. So I'll sum up the question, Laura, and then.
This thanks for really interesting. There's a lot of focus on enteric methane there in particular. We sort of ascertain the fact that there is sort of general enteric pipes outside the top of methane. We've seen a big increase in the poultry flock. Just wondering how that might be feeding into the inventory. Yeah, obviously, because your storage doesn't quite get really extended to storage in that regard. Are we seeing an increase in methane from that? Because we see quite a large increase in nitrogen oxides, which would be very complementary.
Okay, so just for those online, if you didn't catch it, the question is about the impact of the growth of the poultry flock on the statistics in the inventory on methane emissions.
So poultry, some of the manure for poultry will be used for fuel, for example. So that's exported out of the farm. Is the increase in population again will affect methane, because obviously there's more manure, but also the management of the poultry systems in the UK. So the reason of the way the animals are taking out the house, and the cycles of the lifespan of the animals, means the animals are taking out the house is cleaned up, and then more animals come in. So all of that needs to be taken into consideration. But yes, if there is an increase in poultry, then obviously the manure will increase, and that manure is being used for fertilization. Yes.
Okay, thank you. Question over here from. Yeah, we have time.
So, see drop off in the just effects, because once you go the leaves into the ground, temperature is going to stay all year round. So it's taken into account in the calculations.
Okay, so just for people online, question about the significance of temperature. So it features in the calculations in the IPCC rules and in the way that the inventory is produced. And Chris is saying from some of the monitoring in Cornwall, there's a question mark over whether temperature is really that significant. Any thoughts, Laura?
So if you are referring to the farms in Cornwall, if methane is being actively removed from the tank, and I guess you are talking about the temperature in the actual manure rather than the air temperature.
Slurry temperature in the lagoon.
Yeah, so if you are actively removing the methane, then obviously temperature won't have the same effect. So in this case, the assumptions are that the tank is open and it's a passive emission. It's not an active emission. You are not drawing methane out of the tank. Yeah. So there should be some effect, but maybe, well, I don't know the circumstances, whether the daily cycle is quite significant. I don't know. Yeah. Okay.
Okay, well, first topic already identified for chat in the coffee break. We've got a couple of hands up over there, and let's just go online first. Is there one online, Jez, that you'd like to pick up?
So the question online is from Katie Tomlinson from BDO. Who goes to the last one? Have you done any modelling on how climate change affects emissions?
Okay, so the people online will have been able to see this question, hopefully, but it's about the impact of climate change on these sort of emissions.
So personally, no modeling really. I think one of the issues with manure is there is not a lot of data, certainly not in the UK. And I think when you were talking about emissions, there isn't much data, there aren't much measurements, which is something that obviously we are interested to obtain. But there is so for models we need data. So we, in order to have good modeling, we obviously have to have data so we can validate and verify the model outputs. And as I said, there isn't a lot of data. Some modeling is happening on application of manures to soil, for example, but actually on emissions from storage, I'm not so sure there is much modeling done in that.
Okay, thank you. I think we're going to take one more and then we'll move on. So if there are more questions in the room, have a chat over coffee with Laura. So a question there.
Any influences on emissions from your forming measured by a current method, or which have impacts that aren't being considered well?
So are there any influences on emissions that we think be poorly measured, Laura?
From manure tanks, you mean?
Any.
Well, I mean, obviously the IPCC gives us an equation that we can use to calculate the emissions. As I said, the better data we have to understand how emissions are affected by environmental factors, then the more we'll be in a position to calculate emissions. So, yeah. I think, what I was going to say, as I said, the big note is the potential for manure to produce methane. So that potential, if you wanted to maximize or you wanted to minimize, then you need to really study the factors that are influencing that. And you might want to maximize if you want to harvest methane, you want to maximize the potential. But if you want to mitigate it, then obviously you have to understand the factors that will decrease emissions. But again, and I would like to point out, it's not just methane that is affected. N2O will also be affected, and obviously ammonia. Anything you do to a manure is going to affect all the greenhouse gases and the other pollutants. So we need to think wider than just methane.